the potential on a point due to a sphere. We have already seen the spherical shell. Now, due to a sphere, I am considering a point P at a distance r from the center. Let me consider the radius of this ring to be some r. So, to find out the potential on this point P, I need to divide this sphere into numerous tiny spheres. Let me consider. So it's made up of lot of concentric circles. Let me consider any one such sphere. Sorry. This stays. This is R. Sorry, this is capital. And this sphere, let me say, has a radius x, and I will consider that this has a thickness. This has a thickness of dx. Okay. So my sphere has a radius x and it has a thickness of dx. So what do I have to find out now? I have to find out dv due to this sphere. So dv is equal to minus gm by r. So which means I need to find out mass and I need to substitute for that. For finding out mass, density is equal to rho. So area is equal to 4 pi x square, right, into dx, right? Sorry, area is 4 pi x square and the thickness is equal to dx. So I am speaking about a three-dimensional object. So the volume here, so far we have seen area into rho. Here now we need the volume. So volume is equal to this area into this thickness. So what is the area here? Area is 4 pi x square and thickness is dx. And mass is equal to volume into density. So what is dv? dv is equal to minus g 4 pi x square dx rho divided by r. So this is the potential due to this ring. So obviously what do we need to find out? We need to find out the potential due to the entire sphere. So v is equal to integral dv is equal to integral. So what are the limits? So the distance starts from here and goes up to here. So the limits are going to be, so limits, sorry, this is, it is due to the sphere, right? So which means the effect will start here and the effect due to every element on the sphere will continue until it comes here. So your limit is going to be 0 to r. Your limits are going to be 0 to r, and you can say minus g 4 pi x square dx rho by r. So v is equal to, so minus g 4 pi rho by r is a constant, and x square on integrating is going to be x cube divided by 3. So what are you going to get? Sorry, I missed a 4 here. You're going to get v is equal to minus g 4 pi rho by r, right? Into r cube divided by 3. So what am I going to get here? Minus g 4 pi rho r square divided by 3. This is going to be my potential uh, on a point which is outside the shell. So now look here, this 4 pi r square, let us leave it as r square, r cube itself. So what will I have here? Sorry, give me a minute. Now look here. 4 by 3 pi r cube is the volume of the entire sphere. And into rho will give you uh, m. So 4 pi by 3 into r cube is the volume of the sphere. Into rho will give you the mass. So you have here V as equal to minus gm by r. So this is the potential on a point outside the shell. Okay. Now we need to see the potential on the shell. Actually, this is fairly straightforward. So potential on the shell. So so my radius is capital R. Potential on the shell, which means it can lie anywhere on the shell, which means you can say V is equal to minus gm by r. This is rather straightforward. On the shell, it will lie anywhere on the shell. So anywhere you take, the distance is going to be r. So minus gn by r is the potential on the shell. So we are going to now move on to the third case, which is potential inside the shell. That is going to be a little demanding, right? What's happening? Sorry. Inside the shell. So for that, again, let me consider a sphere. So this sphere has, sorry, sphere has a radius. Sphere has a radius r. So let me consider the point somewhere here at a distance smaller. Okay, it is lying inside the shell at a distance smaller. So if you need to find out the potential on this point, you need to find out the potential due to the inside element, and you need to find out the potential due to the outside element and then add. So potential due to inside is equal to V1. So V1, I need to find out V1 is equal to minus Gm divided by the distance r. So what is the distance from the center to here? It is minus gm divided by r. Okay. So what is m here? M is volume into density. So there is a sphere inside. Okay. There is a sphere inside of this, and that sphere has a volume 4 by 3 pi r cube, because entire inside 4 by 3 pi r cube into rho will give you the mass divided by r. So V1 is equal to minus g 4 by 3 pi r square into rho. That is going to be your Vm. Now we'll have to find out potential due to outside. So that we will consider it as equal to some V2. Now to find out V2, so we are now going to find out V2. V2 is equal to minus G. So let us take any small ring here. Some small ring outside this point. So again, it's the same procedure. Potential due to this ring, then we integrate for the entire thing. So potential due to the small ring of radius x and thickness dx. So now it is going to be minus G 4 pi x square dx into rho divided by x, where x is the radius, dx is the thickness. So x and x are going to get cancelled. So V2 is equal to minus g 4 pi x dx into rho. So what do we have to do? Now this has to be integrated. Okay. So this is dV2. So for V2, we need to integrate dV2. So what we have found out is dV2 for one particular shell. Now we are integrating for the entire sphere. Okay, so we integrate minus g 4 pi x dx into rho. And what are the limits? So outside means it starts here and ends here. So what is this? This is R. So this is R and ends at capital R. So what do we have here? Minus g 4 pi rho x square by 2 between limits R plus capital R. So minus g 4 pi rho R square minus R square divided by 2 is your V2. So last step, we now need to find out the total potential. So I will call it Vt, which is equal to V1 plus V2. Let me fetch V1 first. Sorry. V1 is, where do I have V1? I have it right here. Minus G 4 by 3 pi R square rho. So minus G 4 by 3 pi R square rho plus V2 is minus G 4 pi rho minus G 4 pi rho R square minus R square divided by 2. Okay, now what I do here is I'll take the minus outside. Minus G 4 by 3 pi R square rho, okay, plus G 4 pi rho R square by 2 minus G 4 pi rho R square by 2. Remember, I have taken the minus outside. So what do I have here? I want to take this G 4 pi by 3 into rho as common. So which means I have R square here plus I do not have a 3 in the denominator here, but I have taken 4 pi by 3 outside, which means I'll have to, yep, multiply by 3. So you will have 3 R square by 2. And similarly here also I will have 3 R square by 2. So what do I have here? Minus G 4 pi by 3 rho taking LCM 3 R square plus 3 R square. Uh, mm, it's 2 R square, I'm sorry. It's 2 R square plus 3 R square minus 3 R square. So you will now have here V total is equal to minus G 4 pi by 3 rho 3 R square minus R square divided by 2. 3R square minus R square. Now multiply and divide this equation by R cube. So Vt is equal to minus G 4 pi by 3 R cube into rho by R cube 3 R square minus R square divided by 3. So 4 by 3 pi R cube is the volume of the sphere. What is rho? Rho is the density of the sphere. Volume into density is going to give you mass. So Vt is equal to minus G m by R cube 3R square minus R square divided by 2. This is the volume uh, for a point inside the shell. So we have done volume for a point outside the shell, on the shell and not shell, sorry, outside the sphere, inside on the sphere and inside the sphere, right?